Okay, let's get right into it. We're going to be talking about a really huge event in recent history, the Deepwater Horizon disaster. It's still the largest accidental marine oil spill ever. This all happened back in 2010, but the story of what went wrong is, well, it's pretty mind-blowing.
It is. And to really get it, you have to understand the setting. Deepwater Horizon was this massive floating oil rig. It wasn't just anchored, it was huge. And it was way out in the Gulf of Mexico, about 41 miles off the Louisiana coast.
We're not talking about shallow water here.
Not at all. The water itself was about 5,000 feet deep. That's almost a mile straight down. And then the well they were drilling went another 13,000 feet into the seafloor.
Wow.
Yeah, so the pressure and the conditions down there are just extreme. It makes everything incredibly difficult and dangerous.
That context is so important. So what actually happened? What was the spark? We know the date was April 20th, 2010.
Right. That night, there was a series of failures that led to what's called a blowout. The simplest way to explain it is that a cement seal deep in the well failed.
The plug, basically.
The plug, exactly. And a massive bubble of high-pressure methane gas shot up the pipe, bypassed all the safety systems, and once it hit the air on the rig, it ignited.
And the explosion was catastrophic. The first thing we have to remember is the human cost 11 workers went missing and were never found.
And the rig itself burned for more than a day. Just this giant fireball in the middle of the ocean. And when it finally sank, that's when the next disaster started.
Because it broke the pipe on the way down.
It did. The main pipe that connects the rig to the wellhead on the seafloor, it snapped. And that created an open faucet for crude oil to just gush out into the Gulf.
For how long? That's the truly shocking part.
For 87 straight days.
87, so almost 3 months of oil just flowing out. Do we know how much?
The official estimates are just staggering. Scientists calculated that over 4 million barrels of oil were released. That's something like 170 million gallons.
It's hard to even picture that. What does that look like in the ocean? We hear the term oil slick.
Well, imagine this thick, dark, black oil, which is lighter than salt water, so it floats. And the wind and currents just start spreading it out over thousands of square miles. It's like this giant toxic blanket on the surface of the ocean.
So once that starts spreading, the clock is ticking. How do you even begin to fix a leak that's a mile underwater?
You can't send divers down. It's just too deep, too much pressure. So everything had to be done with remote-controlled robots, ROVs they're called.
So engineers are on a boat using joysticks to control a robot a mile below them.
Exactly. It's like performing surgery with giant robot arms from a mile away. And their first few attempts, they didn't go well.
What did they try?
Well, one idea was called the top kill. They tried to pump tons of heavy drilling mud and, bits of debris down the well, hoping to clog it up and push the oil back down.
But the pressure was just too strong.
Way too strong. The oil just pushed it all back out. Then there was the containment dome.
Right, the giant metal box. I remember seeing that on the news. It looked like a building they were lowering into the ocean.
It was a 100-ton, 4-story structure. The idea was to place it over the leak and then siphon the oil up to a ship. It seemed like a good idea.
But it failed almost instantly. Why?
This is a fascinating bit of science. The water on the deep sea floor is near freezing. When the high-pressure natural gas from a well mixed with that freezing cold water, it forms something called methane hydrates.
What are those?
They're like ice crystals, kind of methane slushy. And it immediately clogged the opening at the top of the dome, making it totally useless. It actually became buoyant, and they had trouble keeping it down.
So after months of these failures, what finally worked?
The first success came in July. They managed to use the robots to cut off the broken, mangled pipe and then bolt a much smaller, tighter-fitting cap directly onto the wellhead. That finally stopped the flow.
But that was just a temporary fix, right?
Temporary seal, yeah. The permanent fix was even more amazing, really. They had to drill a whole new well called a relief well.
From a different spot.
Yes, they started drilling from a ship a couple of miles away and had to drill down thousands of feet and then curve the drill bit to perfectly intersect the original well bore, which is only about 9 inches wide.
That sounds completely impossible, hitting a tiny target miles underground.
It's an incredible piece of engineering. They use all kinds of sensors to steer it. But they did it. In September, they finally hit the target and were able to pump cement in from the bottom, sealing the well for good.
That whole timeline from April to September is just devastating. Let's talk about what all that oil actually did to the environment.
It was horrific. On every level, you start at the surface with seabirds, the oil gets on their feathers and they can't fly. But it also destroys their waterproofing, so they can't stay warm. They freeze or drown.
And what about bigger animals like dolphins?
They have to come to the surface to breathe, so they were inhaling toxic fumes from the oil for months. It caused lung disease, skin problems. It was awful. But the damage went even deeper, right to the bottom of the food
Lots
chain.
of smallest organisms.
Yeah.
Exactly. Tiny plankton, which everything else in the Gulf eats, were poisoned by the oil. When you poison the very base of the food web, that poison works its way all the way up. And we now know the effects weren't just immediate. Scientists have been studying this for years.
Yes, and what they found is really alarming. For example, many fish that were born after the spill, their parents were exposed to the oil, and these young fish had serious heart defects and other health problems. The damage is, it's genetic. It gets passed down.
So this is a problem that will last for generations of animals.
For some species, yes. Scientists say it could take many, many decades for some populations, like deep-sea corals or certain whales, to recover.
And it wasn't just the deep ocean. The oil eventually made it to the coast.
And it hit some of the most important and fragile habitats we have, especially the coastal marshes in Louisiana and Mississippi. These wetlands are like nurseries for the ocean.
Why is oil in a marsh so much worse than on a sandy beach?
Well, on a beach, you can kind of scrape the top layer of sand off. It's hard, but possible. In a marsh, the oil soaks deep into the mud and kills the roots of the marsh grass.
And the roots are what hold the land together.
Precisely. Without the roots, the land just erodes, it washes away into the sea. You're talking about permanent land loss.
This brings up a huge controversy in the cleanup effort, which was the use of chemical dispersants.
Yeah, this is probably the biggest debate from the whole response. They used over 1 million gallons of a chemical called Corexit.
What does that do?
It's basically like a powerful dish soap. They sprayed it from planes onto the oil slicks to break the oil up from a big sheet into tiny little droplets.
The idea being that it would be better to have tiny droplets than a giant slick hitting the beaches.
Right. And it did keep some of the oil off the coast. But there was a huge trade-off. By breaking the oil into droplets, it didn't float on the surface anymore. It stayed suspended in the water from the surface to the seafloor.
So you're exposing a whole different part of the ecosystem.
Exactly. All the deep-sea life, the fish, the corals that normally wouldn't see surface oil, were suddenly living in this toxic cloud of oil and dispersant chemicals. And some research suggests that mixture is even more toxic than oil by itself.
It's a terrible choice. Do you save the beaches or the deep ocean?
It's an impossible environmental dilemma, and we're still studying the consequences of that choice today.
Let's shift to the people. The immediate economic fallout for communities along the Gulf Coast was it was devastating.
Absolutely. Think about the fishing industry. Shrimpers, oyster harvesters, fishermen. Their entire fishing grounds were closed, contaminated. Their jobs just disappeared overnight.
And it wasn't just fishing.
No, the ripple effect was huge. Tourism is a massive part of the economy there. Who wants to go on vacation to a beach covered in tar balls? Hotels, restaurants, charter boat captains, everyone suffered. The oil company ended up paying billions in compensation, but it took years for those local economies to even begin to stabilize.
So let's talk about the actual cleanup. How do you physically remove 170 million gallons of oil from an ocean?
It was a monumental effort. In the water, they used thousands of miles of floating barriers called booms to try to contain the oil. Then skimmer ships would come and literally suck the oil off the surface.
And on the beaches?
That was just hard manual labor for thousands of people. Shovels, rakes, machines, all trying to remove the contaminated sand. And you had armies of volunteers carefully washing individual birds and sea turtles to try and save them.
After the cleanup, the scientists went back to see what was left, and they found something really surprising on the deep ocean floor.
They did. They called it oily snow. Using sonar and cameras, they found that a lot of the oil didn't just evaporate or get cleaned up. It clumped together with sediment and dead plankton and sank.
So it didn't disappear, it just moved.
It moved to the bottom of the ocean, creating this toxic layer on the seafloor, affecting all the little creatures that live in the mud. It's a part of the ecosystem that is completely impossible to clean.
So what's the lasting legacy here? How did this disaster change things?
Well, it forced a massive change in safety regulations for offshore drilling. It exposed huge flaws in the equipment, especially the blowout preventer, the BOP.
That's the main safety device that's supposed to stop this from ever happening.
It is. So now there are much stricter rules, better backup systems, more inspections. It was a very, very painful lesson for the industry and for the government.
And maybe a bigger lesson for all of us.
I think so. The disaster was this really stark reminder of the huge risks that come with our reliance on fossil fuels. It definitely pushed the conversation forward about investing in cleaner, safer energy sources to avoid anything like this ever happening again.
The lessons learned from this about the deep ocean, about the long-term damage, they really continue to shape how we think about protecting our oceans.
It really forces us to ask that hard question.
Hmm.
What is the true cost of our energy? And is it a price our planet can afford to pay?
A really important question to think about. Thanks for joining us today, and good luck with your studies.